Hello everyone. Today I'm going to explain the Floyd-Martin algorithm called as FM algorithm. So this algorithm is used for mining of the data streams, and first of all we need to know that what is a data stream. So a data stream is a continuous and ordered sequence of items that are flowing with a continuous flow, and it is very difficult to control the order in which these items are going to be appear in the data streams, and we cannot predict the arrival of a particular item at a specific point of time. Another thing about the streams is that it is also not possible to capture all of the stream at once into the memory. So there is no process where we can completely store the data stream into the memory, and then we are applying the computational techniques to process that stream. So since the stream represents an enormous volume of the data arriving at a very high rate, we can only see fragments of the stream, and based on that fragment we need to process the streams, and we need to predict the results for our application. Now, data stream mining is the domain where we are going to address some of the fundamental problems related to the processing and mining of these streams. So one of the most popular problem here is counting the number of ones in the window of a bit stream, for example. Then the second problem is to finding the distinct element and counting those elements from the stream. The third problem is the filtering the elements of the stream, etc. So these are some of the fundamental problems that we see, and we try to create the algorithm that can solve these kind of questions for us. So today we are going to take the problem of counting distinct element from a data stream. The same algorithm can be applied to the databases, where we can find out how many unique items or the elements are present into that data set. So basically the Floyd-Martin algorithm was proposed in 1983 by two scientists, the Floyd and by Martin, and this algorithm is used to find the unique number of elements into a particular data stream. The algorithm takes one pass over the input stream, whatever fragment or the window we are considering at a particular time, and based on that window it takes or it counts actually the number of unique elements present into that particular stream. It takes less memory space during the execution, so the advantage we are going to talk about later in this presentation. Now this is the pseudocode of the FM algorithm, and as we can see, the first step here is to select an appropriate hash function h, and each element in the set is mapped to a string of at least log n bits by this hash function. So we are taking the elements, we are applying this hash function h, which we have selected. There could be more than one hash function we can choose for the same algorithm to work, and whatever the output we are getting for this particular application of hash function over the element, that we are saving as a string. In a second step, for every element of the stream, we are calculating Rx, and this Rx is what? This Rs is basically the length of the trailing zeros that we are counting for each and every application of hash function h over the element x. Now, once we have completed this step, then finally we need to find out the value of capital R, which is the maximum number of the trailing zeros that we have calculated in the previous step, and this gives us the distinct elements by raising this small r to the power of 2. So this is one of the example that I have taken today for showing how this FM algorithm is going to work here. And for example, we have been given the input stream like this: 1 3 2 1 2 3 4 3 1 2 3 1, and we have to find the count of distinct elements from this given stream by using the FM algorithm, and the hash function which is given to us is hx is equal to 6s plus 1 mod 5. So step 1 says that we need to first apply the given hash function to each element of the stream, and we have to find the hash values. So here we are calculating the hash of each and every element of the stream. As you can see that the first element here is 1. So we are applying the hash function here over 1, and hash function, as you remember, we have taken as, for example, h of x is equal to 6x plus 1 mod 5. So 5. So this is the hash function we have selected. So when we are replacing x by the stream element, so for example, when we are calculating for h1, we are getting 6 multiplied by 1 plus 1 mod 5, and if we solve it, we will be having 7 mod 5. So this gives us 2. So thereby we are having a value of 2 here. The similar step we are performing for each and every element of the stream. So we can see that for h3 we will be having the value of 4. For h2 we are getting 3. Then for h1 we are getting a 2. For h2 we are getting a 3. So this way we have counted and find out the value of this, or the output of the hash function for each and every element of the stream. Once this step is done, we need to proceed forward to the step 2. In step 2, what we are going to do, that we are going to represent each hash value as a binary string. So as we have discussed in the pseudocode of the algorithm, the step 2, we are creating binary strings. And how we are creating that? So it is very easy. For example, whatever hash value or hash output you get, you just have to convert it into a sequence of zeros and ones. So for example, here for the encoding purpose, we have taken the binary string length as 3. So we are representing each and every output of this hash function with a string of zeros and ones of length 3. So for example, for 2 we are representing as 0, 1, 0. For 4 we are representing 1, 0, 0. For 3 we are converting it to the binary value, which is 0, 1, 1. And similarly, we are repeating the same process for the other element. And as you can see, for h4 we will be getting the output of the hash function as 0. So 0 in binary, we taking this and encode it into a 3-bit string of all zeros. So this way we have proceeded for each and every element of the stream. Now we move to the next step. So in step 3, what we are going to do, that we need to find out the trailing zeros from each of these binary strings that we have created in the step 2. So how we are going to do that? So for counting the trailing zeros, how we are proceeding here, that we need to start from the right hand side of the binary string from here, for example, and we need to see how many zeros we are getting from right hand side, and we are moving towards the left hand side until we encounter a 1. So for example, in this case, this is the first one we are encountering when we are moving from right to the left. And as you can see, since only one trailing zero we can find out before the first one from the right hand side, we are counting it 1, the number of trailing zeros in this case. In this case, we are moving again right to left, and we are counting the number of zeros until we find a 1. So in this case, the number of trailing zeros we find out is 2. Similarly, we process the same step, and we apply to each and every element. And for every binary string, we are counting the number of zeros. In fact, not the number of zeros, the trailing number of zeros. So we have to always remember that we need to count not the number of zeros from the binary string, rather we need to find out the trailing number of zeros. So trailing zeros, that is a string of zeros that appears after a certain occurrence of 1. So here, if we are moving from right to left again, we can see that this is 1, this is 1. We have not encountered any zero till now, and this is a 0 which we have encountered, but before that there is no 1, so we cannot say that this 0 is a trailing 0. So this does not, clears the criteria for a trailing 0. So that way we have written here as 0. Similar ways, again for 0, 1, 0, we have 1 trailing 0, this one. For 0, 1, 1, again no trailing zeros we can count. And for 1, 0, 0, since this is 1 and after this 2 zeros or 2 trailing zeros are there, so we count it as 2. So this way we have repeated for each and every element. And finally, now we have to find out the value of r, and this value of r will be the maximum number of zeros that we have encountered in the previous step. So you are going through or scanning your table once, and you will see that which is the largest or the maximum number of zeros that you have recorded into that table. So as we can see in the previous step, you see the maximum number which occurred here is 2. So maximum number of trailing zeros that we have encountered for the given string is 2 here. So this becomes the small r. So we have kept it as r is equal to 2. Now we need to apply the formula, and this formula is nothing but that we whatever r value you are getting, you just have to raise it to the power of 2. So we need to find out 2 raised to the power 2, and that way the algorithm gives us the number of unique elements here as 4. If you verify it with the stream which is being given to us when we are solving the example, we can see that 1, 2, 3 and 4, these were the unique element that we have got. Here in this case I have written it as 1, 3, 2, 4, which is exactly the sequence in which these unique elements have appeared into the given stream. So sometimes you can write it like 1, 2, 3, 4, but to maintain the sequence that how we have encountered these unique elements as per the stream sequence, that way 1, after that 3, then 2, then 4. Now this is one more example how what will happen if we apply the same hash function 6x plus 1 mod 5 to another instance of the problem. And here what we have done, that we have taken another element which was not present into the previous stream. So for example, if we need to process this type of stream right now, and we have taken the previous hash function which we have taken up to solve the previous instance of the problem, what will happen? So in this case, the first step we are applying, and we are finding out the value of hx. How this hx we are going to find out? We are applying for every element the value of hash function. So for example, we need to calculate h1, then we need to calculate h3, then we need to calculate h4, then we are calculating h1, h5, then h of 2, h of 2 again, then h of 3 again, h of 4, and then h of 1, h of 1. So now we have to calculate these values by applying the same hash function, which is 6x plus 1. So we are replacing the value of x here, and we are solving for this expression, and then we are getting some value. So if we remember previously that if we apply this hash function for value of 1, we will be getting what? We will be having 6 plus 1, 7 mod 2 mod 5, so we will be getting a 2 here. Then for 3 we will be getting 6 multiplied by 3, which is 18, and then we are adding 1, so it will be 19 mod 5, and we will be getting an output as 4, right? The similar way we need to find out the other values. So here we will be getting a 0, and for this h1 again we can repeat the same. For 2 For 5 we have not solved yet, so we will again solve it out. So 6 5s are 30, then 1 31 mod 5, so we will be getting 1 here. Similar ways for 2, 6 2s are 12 plus 1 13, we mod it by 5, so we will be getting remainder as 3. So this way we are replacing, because we already have solved all the unique instances here, so you can repeat. You can see for h1 we already have calculated, and this gives us a 2, so we are replacing like this. Now for 3 we already have calculated as 4, so we are replacing 4 everywhere wherever we are finding h of 3. And similar ways, this is h of 4, we already have calculated it as 0, so we are replacing it here. Once we have find out the output of the hash function, then we are converting it to a binary string. So here we are writing the binary string, and for example we again take the encoding as of length 3, then 2 we are representing it as 0 1 0, then similarly for 4 it will be 1 0 0, for 0 it will be 0 0 0, for 2 again 0 1 0, then for 1 it will be 0 0 1, for 3 it will be 0 1 1, then for 3 0 1 1, 4 again it will be 1 0 0, 0 0, and then for 2 again we are getting 0 1 0. So this is the second step. Once we have find it out, we need to find out again the trailing zeros. So tz we are finding out, like for example, for in this case the number of trailing zero is 1 2 0 1. In this case it is 0, again it is 0 0. In this case we have 2 0 and 1. Now what is the largest value that we have found out here in this step? So 2 is the largest value that we have found out. So now we need to find out r, that is a number of unique elements, as 2 raised to the power 2. So this again gives us 4. Now if you check it with the given stream, we can see that we have 1 3 4 5 and 2. So there are 5 unique elements that are present in actual data stream, but what answer we are getting here is only 4. So now why we are getting 4 as the answer? So there are certain things that we need to keep into our mind when we are dealing with or we are using the FM algorithm. First of all, that the selection of the hash function is one of the key element of applying the algorithm. So when you are trying to apply your algorithm, the selection of an appropriate hash function is the key that you need to remember. So for example, as I already have mentioned, I can also take multiple hash function and I can solve this or apply this algorithm steps afterwards, and that is going to increase the accuracy of the results in many cases. So it has been found out that if you are taking more hash functions, the accuracy level of the algorithm will be increased. Another aspect here is that since the FM algorithm is an approximate algorithm, so it generates the approximate solutions. So it is not we cannot have a guaranteed solution which will be matching the exact solution. Rather, it gives us a quick answer within a given time frame, which is required in most of the applications, and which is a critical aspect of many of the applications, that we need quickly the answer, and we need an approximate answer, and we are happy with that answer even if it is closer to the exact solution, and it is not the exact solution, we are fine, but we cannot wait for a longer time to get the exact solution, because that that kind of problems are time critical or time bounded. So basically we have to keep in mind that when we are applying the FM algorithm, in some cases we will be having the exact solution, but for some other cases we cannot have the same solution, rather it will be giving us an approximate solution, and we are happy with the approximate solution if it is giving us more accuracy. So for example, if we are getting a value of 4 and it is quite close to the the exact number of the elements, the unique elements that are present into the stream, we are happy in most of the cases. Right now it looks awkward because we are only having a small stream, but when your data size is getting increased and you are having a very lengthy stream where thousands or millions of the data items are present, in that case, if if for example there are 50,000 unique elements that are present into the stream actually, and your algorithm is predicting that you have for example something like, for example, 49,569. So these many unique elements. So this is too close to the exact solution, and we can approximately have an idea that how many unique elements the algorithm is that are actually present into the database or in the big data stream which we are processing. So we are fine with that solution. Now, what are the strengths of the FM algorithm? So the first thing is it is very memory efficient. It takes less memory, and it is faster because the computations are quite simpler. The third property is that it is scalable. So even if your big data size is going to be increased by larger magnitude, again the FM algorithm is giving you approximate answers within a given time bound. Now, some of the drawbacks of the algorithm, as we can see that it is sensitive to the hash function parameters. So, for example, whatever hash function we have used in the problem, the given problem where we have solved some example, we have taken it as hx is equal to 6x plus 1 mod 5. Now, these are the parameters. So, x is the actual element of the stream that you are processing here. This 6, this 1 and this 5, these are actually the hash function parameters, and we can denote them as a, b, c here. So I can write that my hash function is of the form ax plus b mod c, right? So whatever parameters you have selected for your hash function, that critically determines the efficiency of the algorithm. So how close you will be to the final solution or the exact solution, that will be determined by the settings of A, B and C parameters into your hash function. Another thing, it is a randomized and approximate algorithm. So as I already have explained that we can expect to have an approximate solution for the given problem. So it does not guarantee that all the time we will be getting a perfect solution. So thank you very much for